So today we're adding in, really it's one more property, but we're going to show it as two because it applies to having one thing inside the parentheses versus having more than one thing inside the parentheses. This is going to be the rules for power on power when we're dealing with exponents. So the first one looks like this. Anytime you have a power on a power, which we talked about already because she asked a very good question, why don't you multiply? So right here, you have a power on power, you are going to multiply the exponents. So if you have something like this, where you had a to the m, and it was raised to the n power on the outside of the parentheses, you would be multiplying that n times the n to get that answer. Real life example, if we have something like this, and it is a to the third raised to the second power, you would be multiplying that, and this would be a to the what? 6. Perfect. Guys, do you see that this is different than a to the third times a to the second? What would that answer be? A to the what? To the fifth. Good. A to the 5. Perfect. You have to know the difference between these two. When you have power on power, you multiply. When you have multiplying like bases, then you add their exponents. Power on power, you're going to multiply. When you multiply like bases, you add their exponents. Everybody see the difference? Anybody have a question? Okay, guys. So from here, we're going to apply this and go through and do a bunch of problems. Make sure you got this down. These are pretty straightforward, these first few. So when you have a power on power, you multiply. So this has got a 4 raised to the 7th power, 4th power raised up to the 7th, so this would be x to the what? 28. Good. Next one is going to be fraction times a fraction, so grab your calculators. You're going to multiply 2 fraction button 3 times 1 fraction button 2. 1/3. Perfect. Y to the 1/3. The next one, again, use your calculator. You're going to be multiplying a whole number and a fraction. You're going to multiply 3 times 2 fraction button 5 equals. Now, my guess is you're going to need to have to do the second fraction button. It's probably an improper fraction. What's it give you?
6/5.
6/5. There you go. Anybody have any questions typing that in the calculator? Anything about any of that rule? When you have a power on power, you've got to multiply. We're good? Okay. Baker, you with us? I can't see you. Okay, I just can't see you. Guys, y'all know I ask on this side if I can't see your face. Make sure you're with us. Here we go. Next one. Guys, this is the two rules combined. Listen to me. This is the stuff from before combined with this stuff. Here we go. You have this power on power to this one right here. Is the y to the third inside that parentheses? No. So you just rewrite the y to the third, and it's going to be multiplied by y to the, and then we have to multiply this -2 times this 5/2. So grab your calculators, type 5 fraction button 2 times 2 negative equals -5. There we go. Okay, now that we have this, what do we do with these powers on these like bases? Add them. Wonderful. That's going to make it y to the -2. Can that be my answer? No. We put a 1 underneath it. We draw a new fraction bar. It's the same, guys, it's that same part. Anytime you have a negative exponent, make it into a fraction, move it to the opposite side. So you've got this y to the -2. It needs to move to the bottom. It's going to become y to the 2nd. Since we have nothing on top, we put a placeholder of 1. So it's not that bad, guys. Okay, here we go again. Does the x to the 2nd need to be multiplied by the 4? No, it's just x to the 2nd. The one on the inside of the parentheses is the one that we multiply that by. So it's going to be x to the -24th. Good deal. Now we add those exponents. 2 plus negative 24, or in your calculator, 2 plus 24 negative equals negative 22. And then we're going to make it a fraction. We're going to move it to the bottom and make it positive 22. And we put a placeholder of 1. It's really not that bad, guys. Okay? And actually, kind of, most people do better once they see this rule on the old rules. Kind of makes a connection, and they start getting the other ones better. Okay, now this one is different. This one, it's the first one that has to be distributed to right here. This negative 1/2 has to be multiplied by this negative 5. So grab your calculators. What is 5 negative times 1 fraction button 2 negative equal? I think it's positive 5 over 2, because a negative times a negative should be a positive. Yeah. Be careful. Yeah, you have to watch for that carefully on your test, guys. I printed it on the good printer, but still, you still have to look carefully. The test is printed on the good printer. You'll know we got a good printer and a bad printer. Okay, then you've got to multiply that times b to the 3/2. What are we going to do with these two fractions? Add them. What is 5 over 2 plus 3 over 2? 8 over 2, but 8 over 2 is 4. Got to reduce. There you go. Perfect. Guys, see any questions on the rules so far? Okay.
I did not even realize there was a back.
Oh no, yeah, I separated it into the ones that have just one thing on the inside of the parentheses. Now this is going to have like more than one thing on it. It's the same rule. It just happens to have more than one thing inside the parentheses. Okay, here we go, guys. Ready? Okay, here we go on the back. When you raise a product to a power, all that means, guys, is that there happens to be more than one number inside this parentheses. So instead of taking and putting the n to just one of them, you have to apply it to everything that is inside that parenthesis. Guys, did I make it clear enough? I wrote it on here for you. I underlined it. I'm highlighting it now. It has to apply to everything inside there. So it's going to be a to the n and b to the n. In real life numbers, when you think about it, this 4, again, applies to both the things inside here. So it's going to be 3 to the 4th and x to the 4th. Can I leave an answer like that? No. Listen, you cannot leave a power on a number when there is a variable in the problem. If there is a variable in the problem, you must work out the 3 to the 4th. Grab your calculators, do 3 power button 4 equals 81 x to the 4th. Do y'all see it's the same thing? It just happens to go to more than one thing on the inside. Is that part okay? Okay. So I did a set of problems to practice it, and then I kind of have 2 little sets of problems that are going to kind of put everything together that we did in the notes today. They're a little more complicated to make sure that we see as hard a problems as you're going to see on your homework. So here we go. Okay, first the basic ones. The 3 has to be applied to everything inside here. So it's going to be 7 to the 3rd and m to the what? 27. It's a big number, guys, but it's okay. It's a big number. Gotta multiply. Okay, from there, what is 7 power button 3 equal? 343 m to the 27th. Thank you. Okay. This is a negative 4 to go to both these. We're going to apply it to both of them. So it's going to be 2 to the negative 4th and z to the negative 4th. But guys, they're both negative exponents. They both need to move to the other side. So I've got to draw a fraction bar. I've got to put my 1. I've got to draw another fraction bar. Since they're both on the top, they're both going to move to the bottom. When they move to the bottom, the power is going to become what? Positive. What do I put on top? 1. And then I do need to go that one more step because I have a number with a power on it when there's a variable in the problem. When there is a number with a variable on it, with a power on it, when there's a variable in the problem, you need to go ahead and work that out. What is 2 to the 4th power?
16.
16z to the 4th. Nice. Nicely done, guys. Okay. So again, another negative power. It's going to be distributed to both of them. It's going to make it 3 to the negative 2. G to the negative what? 8. Good. Negative 8. They're both negative powers. Because they're both negative powers, I have to draw my fraction bar. I have to put my 1. Whenever you have negative powers, they're going to have to switch to the opposite side. Since they're on the top, they're going to have to switch to the bottom to become positive. We don't have a number up here, so we'll put placeholder of 1. I can't leave the 3 squared in the problem. We should need a calculator for 3 squared. What is 3 times 3? 9. G to the 8. There you go. Y'all seem to be doing better with this rule than you did the first time we kind of talked about exponent rules. You seem to be kind of connecting things. Anybody have any questions before we do the last problems? Okay, here we go. So, guys, powers have to be done on the outside first. The rules are exponents get done before you start multiplying things together. So I've got to distribute this exponent to this, and then this exponent goes to everything that's inside here. So this is going to become x to the negative 2 and 2 when they multiply give you negative 4 times 3 to the 4th, x to the 4th, y to the what? 20th. Y to the 20th. Good. Okay, this is kind of unique, guys. Okay, what happens to the x's? Yeah. Because it's x to the 0, and x to the 0 is just 1, which means it multiplies by 1 and it doesn't change it. It's going to basically cancel out. So, we did 2 to the 4th. What's 3 to the 4th? 81, thank you. Y to the 20th. Good. Okay. Any questions? Anybody seeing anything? Okay, here we go. This 4 gets distributed to both the things inside here. That's going to be 3 to the 4th. Oh, grab your calculators, guys. Okay, we got to multiply 5 fraction button 2 times 4. 5 fraction button 2 times 4. What's that give you?
10.
10. And then times c to the, we have to multiply the 3 times the 2. That's going to make it c to the what? 6. Good. So we just did 3 to the 4, guys. We don't need to do it again. What's 3 to the 4th? 81. C to the, what do we do with these powers when we multiply these like bases? Add their exponent, which is going to be 60. Sorry, I gave you the answer there. Sorry about that. Last two, guys. Last two. There's a reason both these last two are on here. Okay, here we go. This last one's like strange number-wise. Gets a very big number. We good? Okay, here we go. So, when you deal with this, we got to take the 3 and put it across. That's going to make it 6 to the 3rd, a to the 3rd, and b to the 3rd. On this side, we're going to have to take that 2 and put it across to everything. That's going to make it 5 to the 2nd, and a to the negative 6th. Okay. Guys, grab your calculators, because you need to do this all at one time. You will do better if you do this. Do 6 power button 3 times 5 power button 2. I'll say it again. 6 power button 3 times 5 power button 2. It's a very large number. What's it give you? 5,400. Perfect. We need to combine the exponents on the a's. What would we get for a to the what? -3. Good. When we add these two together, 3 and -6 gives you -3. And then there's no other b's, so it's just b to the third. What's wrong with it? We're not done. Why aren't we done? There's a negative exponent. You can't leave a negative exponent in your answers, guys. I keep repeating the same thing. The 5400 is just regular old 5400. It's been there. Don't change it. The a to the -3 has got to go to the bottom, become a to the 3. The b has a positive exponent, so it's going to stay on the top. Guys, you got to know when you're done. I didn't say anything. Got to know that it's got a negative exponent. You got to move it. Okay. The last one deals with powers and fractions and other things. It's our last one, so let's make sure we understand it. This 10 gets distributed to this 1/2. This is power right here, power on power. So it'd be, guys, you shouldn't need a calculator. What's half of 10? 5. Y'all all know that. Half of 10 is 5. Then this 3 has to be distributed to all of these things inside here. Okay? So it's going to be multiplied by 4 to the third, m to the third, and n to the, oh, grab your calculators. Hey, multiply 2, fraction button 3, negative, times 3 equals -2. There we go. Okay, guys. So, when we set this up, do y'all see the negative exponent? Put the bar, put the 1. Okay, now, guys, what thing's going to go in front?
Wait.
What's going to go in the front? The number. The coefficient goes first. Yes, please, Markel. The 5? Where's there a 5? I haven't done that yet. I'm going to. That's what this step is going to be. That's what this step's going to
You
be.
do that after.
No, you're going to do it. I'm going to show you why you don't need the fraction bar. That's what I'm going to talk about. So, that's why you're good that you're doing what I wanted you to do. So, do you see, guys, that this is a negative, but if you move it down, you haven't combined yet. So, you would want to combine first. She's absolutely correct. That's what we're trying to make sure you see. These two have to go together before you start putting that fraction bar and deciding that, because you're not going to need the fraction bar. So here we go. First things first. What's going to go in front is this number. What is 4 to the third power? 64. And then the m is going to be the first variable that we put, so it's just going to be m to the third. And then the n is going to go last. What is 5 and -2? 3. There you go. Do I still need a fraction bar? No, that's the whole point. Guys, combine first, then decide if you need the fraction bar. Nice catch, Marco. That was good. Okay.